It's Ms. Haslin, and I'm going to go over the Graphing Inequalities foldable. So first you need to fold it. So we want to fold it over so that we can see all of the different symbols and then have our title underneath. And it does give you a line up here, so kind of fold along this line or close to it. So fold it like this. Then you're going to need to cut the flaps along these lines. They're little dotted lines. All right, so now I have each flap. All right, so starting with the greater than symbol. When we're graphing, I like to think of it as just a equation in slope-intercept form. So think of like y equals negative 3x plus 5. So think of what we already know with graphing slope-intercept form. We want to start with our y-intercept. So first graph y-intercept. So y-intercept is your constant value, that's 5. So we write that as an ordered pair, 0, 5. So then going to the graph, this would be 0, 5 right here. So always start with that. All right, then we want to graph our slope from the y-intercept. So my m value is negative 3. So second graph slope, which in this case equals negative 3. Always turn it into a fraction. Negative 3 over 1. That's the rise over run. And then from our y-intercept, if my rise is negative 3, I go down 3, and then my run is 1, right 1. And just keep going, down 3, right 1, down 3, right 1. All right, now is where it gets different than just a regular equation. Now I have to look at my inequality. Y is greater than. It doesn't have that little line underneath for or equal to. So what this means is greater than symbol means a dashed or a dotted line. Because that we call it the boundary line, it does not include those solutions on it. If it's a dashed line, it's not inclusive. So this is, we call that non-inclusive. So it would mean any points on that line are not included in the solution. So instead of a solid line, and you still would want to use your ruler that you have with your calculators to try to make it nice and straight and accurate. So I'm just going to do little dashes or dots along my line. So it's not solid. All right, then we have to shade our solution region. If y is greater than, then I'm going to shade above line. Now sometimes my students get confused where to shade. They're like, well, how can I tell what's above? Like, I'm not really sure. Well, look at your y value. Like your y-intercept is at 5. So we want to include all the y values above 5. And we don't want to include these ones below 5, so we're not going to shade, so we would shade to the right of it. That's above the line. So then all of these ordered pairs to the right of this line are solutions. And then we still have to identify 2 solutions down here. So what we're going to do is let's test a point. So any ordered pair in your shaded region, I'm going to pick 2, 2 right here. And then plug it back into your inequality to test it. So we're going to test point 2, 2. So my y value is 2, my x value is 2. So I'm going to go back here. 2 is greater than negative 3 times 2 plus 5. All right, solve it. Negative 3 times 2 is negative 6. Negative 6 plus 5 is negative 1. So 2 is greater than negative 1. That is a true statement. So that is a solution. So I know that 2, 2 is a solution. We need another one to identify. So it's any point in this. So I could pick 4, 0. Non-solutions would be points that are in this other region that is not shaded. So this would be any ordered pair over in this region. So I'm going to pick -2, 0. And then also 0, -4. They're not in that shaded solution region. All right, now graphing linear inequalities with less than. So graph the inequality 8 plus 4y is less than 2x. All right, so there's a couple ways you can graph this, but I'm just going to convert it back to slope-intercept form, y equals mx plus b. So I want to get y isolated by itself. So remember, if you're going inverse, first look at the side with the y, the one variable that you're isolating. We first want to do the inverse of add or subtract. So if I see 8 plus, I need to do the inverse and subtract 8 from both sides. Then I get 4y is less than 2x minus 8. All right, now we have 4 times y, so the inverse would be divide everything by 4. Y is less than 2 divided by 4 is 1/2 x. -8 divided by 4 is -2. This is our inequality in slope-intercept form. Again, same steps. First, graph y-intercept, which is your b value, your constant, so that would be at 0, -2. So I'm going to go down here to 0, -2. All right, then we have our slope. So rise over run equals 1/2. So then I know from my y-intercept, I'm going up 1, right 2, up 1, right 2. I also want to have my line extend the opposite direction. So just do the opposite. Instead of up 1, right 2, go down 1, left 2, down 1, left 2. All right, again, go back up here. It's less than, so that's going to be a dashed line again. So using my ruler to make it nice and straight, I'm going to do a dashed line. And then it's less than. So again, y is less than, so we're going to shade below now. If you get confused again, look at your y-axis. If it's on -2, we need to shade the numbers included below y equals -2. So like -4 is down here, so I know I'm going to shade below it. Again, test a point to see if it works. So let's test 2, -2. So if I have 2, -2, y is my -2, so I'd do 2, -2, so I would do -2 is less than 1/2 times 2 minus 2. 1/2 times 2 is 1. 1 minus 2 is -1. -2 is less than -1, so my point checks out. So I know that I shaded the correct region. So again, if you're unsure, especially, or just to be safe, no matter what, always test a point, make sure it works, and then you know you shaded the correct area. All right, so that's one of my solutions to -2. Now pick any other ordered pair that's in the shaded region. It can't be on this dashed line though. That's non-inclusive again. I'm going to do -2, -4. This point would be. Identify two non-solutions. So again, look in this area above the line that is not shaded, or even on the line because it's dotted. So I see that 0, -2 is on the line. That's non-inclusive, so that would not be a solution. And then let's pick a point. I'm going to do -3, 2. Those are either on the dashed line or in the area that is not shaded. All right, next one, graphing linear inequalities with greater than or equal to. All right, 2y is greater than or equal to 4x plus 6. Again, I want to get this in slope-intercept form, so I want to get y isolated. Right now it's 2 times y, so I'm going to divide everything by 2. Y is greater than or equal to 4 divided by 2 equals 2x, 6 divided by 2 plus 3. All right, again, graph your y-intercept, which is our constant value, which is 3, so 0, 3. All right, then my rise over run. So again, turn your slope into a fraction. So if it's just +2, any whole number is over 1, because remember, fractions are division. 2 divided by 1 equals 2. It's an equivalent fraction. So then from this point, I go up to right 1. I'm out of space, so I have to go the opposite direction from the y-intercept. So again, do the opposite, down to left 1. Down to left 1. All right, now I have my points. Now I have to go back to my inequality. It's greater than or equal to. This is going to be a solid line because it's inclusive. It has that or equal to, that little line underneath the inequality. So it's a solid line, it's inclusive. So I'm going to get my ruler, draw my solid line. All right, then going back to the inequality, greater than or equal to. So I'm going to shade above the line because that would be all the y values that are greater than. So if it's on 0, 3, I need to include the y values greater than, so 4, 5, and so on. So I'm shading above the line. All right, again, test a point to make sure that we shaded correctly. So I'm going to test -1, 2, this point. So let's test -1, 2. Go back to your inequality. Y is greater than or equal to, so y is 2. 2 is greater than or equal to times -1 plus 3. 2 times -1 is -2. 2 is greater than or equal to -2 plus 3. -2 plus 3 is 1. 2 is greater than or equal to 1. So it checks out. So we shaded that correct region, so we can include that as one of our solutions, -1, 2. All right, then we can also find another ordered pair. Remember, this line is solid, it's inclusive, so it can be anything on the line. So I'm going to choose the y-intercept, 0, 3 is on the line. Non-solutions would be any points that are outside of that shade region, so any points below this line. So 0, 0 would be a non-solution, and 5, -1. All right, lastly, we have graphing linear inequalities with less than or equal to. So here, again, I want to convert to slope-intercept form. So I'm going to subtract 12x from both sides. That cancels out. We're left with -3y is greater than or equal to -12x plus 9. All right, then I need to get y isolated. It's -3 times y, so I want to divide by everything by -3. Now, we went over this in a past unit, and I don't know if you remember, but if we divide both sides by a negative with an inequality or multiply both sides by a negative, our inequality actually flips. So it would, these cancel out y, and so instead of greater than or equal to, it's going to be less than or equal to. Then negative 12 divided by negative 3 is 4x. 9 divided by negative 3 is minus 3. So flip inequality when multiply or divide by a negative to both sides. Very important to remember that. You will see that on the next assessment. All right, again, graph your y-intercept. So our y-intercept is 0, negative 3. Put it down here. Then we want to do our rise over run. So our slope is 4. So again, make that into a fraction by putting it over 1. So from my ordered pair, or from my y-intercept, I go 1, 2, 3, 4, right 1, 2, 3, 4, right 1. All right, now our inequality is less than or equal to. So it has that or equal to, it's a solid line. And if it's less than, we shade below. So I go back to my ruler, solid line. And then look at your y value. It's at negative 3 here. We want to shade all of the values below it. Always test a point. Let's test 2, 0. So if I plug it back in, 0 is my y value. 0 is less than or equal to 4 times 2 minus 3. 4 times 2 is 8. 0 is less than or equal to 8 minus 3. 8 minus 3 is 5. Is 0 less than or equal to 5? Yes, it's less than. Checks out. So 2, 0 is one of my solutions. And then any other point on the line or to the below it, or kind of, it looks like to the right of it, but it's below it. So you can pick any point. I'm going to pick 5, 5. Two non-solutions would be anything to the left of the line or above it. So 0, 0 would be a non-solution, and negative 3, negative 3. All right, now you're going to take this paper and glue it on the other colored paper that was provided for you, and then you can put it in your 3-ring binder.